Thanks, John. I'm really looking forward to sharing some more information with the audience here today about our telescopic joint packers. And I'm personally very passionate about solving problems on drilling rigs, in particular because I came from a drilling engineering background with a major international operator. Started on U.S. land years ago and then actually moved to offshore Nigeria, where I worked for 4.5 years before I joined Lord and now Parker Lord. And also presenting with me today is Maggie D'Amico, and I'll turn it over to her to share more about herself.
So I'm Maggie D'Amico. I've been at Lord for about 13 years now, Parker Lord, and actually the past 8 years of that working with Jonathan on oil and gas products. So while I wasn't, say, passionate about oil and gas products when I joined the team from the period of time working with him, I've gained some of that passion and hope to share it with you today.
Thanks, Maggie. Today we'll be covering our telescopic joint packer product line, how we developed that product line, what the drivers were. Then we'll go through our qualification efforts to qualify to API 16F, and then also some additional competitive product testing and field results that we've gotten on those packers, and then what you can expect from these packers from a service life standpoint, and the lengths we go to for quality control. Before we tell you the details about the telescopic joint packer product line, I want to tell you a little bit about Lord's history and now part of Parker Lord. We were founded in 1924 up in Erie, Pennsylvania, and were recently acquired by Parker Hannifin in 2019. Our segment of Parker is about $1 billion in annual sales, and we have just within our group at Lord have over 3,000 people globally. We have facilities all over the world, and we serve markets including oil and gas, transportation, aerospace, and defense. And you can see the other ones there. And so what we did about 10 years ago is began a technology transfer from primarily aerospace and defense know-how that we've developed into the oil and gas industry to solve oil and gas problems. And it's been a really fun ride to bring new capability to the oil industry. As we went trying to apply the technologies from Lord's history and capabilities to oil and gas problems, we really divided the business into two segments. And one is our downhole systems business, where we're providing shock and vibration control to improve the reliability of electronics used in directional drilling and logging. And then we have the offshore products division, which we're going to be focused on today, which is providing highly engineered elastomeric parts for high criticality applications like TJ Packers. So how did we end up getting into the Packers and Seals business? We actually went to some of the riser OEMs during this technology transfer phase early in the early days and actually went into them talking about flex joints, because Lord has a long history in drilling riser flex joints going all the way back to 1975. During that discussion, they kind of really shrugged their shoulders at us and said, flex joints are, yeah, it'd be nice to have another supplier for flex joints, but our real problem are these telescopic joint packers. And this was back in the 2011, 2012 timeframe. And they really said they were having issues with the longevity of those, quality issues with those. And they said, can you do something to make those better? And so we took on that challenge. And you can see there that we have done several variants of telescopic joint packers. And the first one was in 2013, and then kept releasing those sequentially through 2018. Also along the way, we ended up doing overshot seals, insert diverter packers, complete shutoff packers for a CSO style diverter. And then we're working on a spherical BOP element, which will be our first BOP element. Again, solving kind of longevity and improving the operational envelope and capability of that using our elastomer know-how. And so that's really how we approach these things. And what we're going to talk about today is, because we have the internal elastomeric know-how, we've developed some special nitrile compounds for the TJ Packer application, and we've developed high strength and high fatigue nitrile compounds for like the BOP application. And we're bringing that aerospace manufacturing and modeling know-how to be able to make it much less hit or miss in terms of build a prototype, see how it works, and then reiterate. We've got better design tools where we can design them up front and design these products up front and have a better idea of how they're going to behave when we manufacture those. At this point, we're going to post our first poll question. Where do you currently purchase your TJ Packers? And we'll give everyone a moment to respond to that. Thanks for your response. Now I'm going to turn it over to Maggie to give you additional background on that product development qualification effort specifically for TJ Packers.
All right, thanks, Jonathan. So I'm going to talk a little bit more about how we developed this product line and specifically some of the lab and elastomer level testing that we've done on our products and our competitors. So, as Jonathan said, we kind of came into this by accident, and really we started back in 2013 with an outer packer. So not a packer that's running on the inner barrel and seeing a lot of abrasion, but the issue they were having was with the outer packer, and specifically with bond line failures, where the elastomer would just fall right off of the metal, and a lot of those were infant mortality failures. So we came up with a new nitrile specifically for that application. And then where it evolved to was working on the wear packers for other riser styles. And for that, we specifically needed to find a material that had better wear properties. So one of the first kind of screening tests we did was the Tabor abrader test. So you see this piece of equipment on the left here. This is a Tabor abrader tester. And you basically have a sample of elastomer that wears against a rotating disc. And during this test, it's an ASTM standard test, you measure the amount of mass that comes off the elastomer sample during that test. So if you want a high wear resistant compound, something that wears really well and has good abrasion performance, then you want a low number for this test. So the first nitrile version that we tried for TJ Packers ended up right here at about 35 milligrams of mass loss during the 1,000 cycle test. And that was the high strength nitrile that we had. We compared it against our competitor's nitrile that was being used, two different competitors who were making TJ Packers. And these here, had substantially higher wear levels than even our like high strength nitrile, but we knew we could do better. And another comparison point that we used was a competitor's polyurethane, and that's a well-known, wear resistant compound. It's very stiff, but it has very good abrasion properties, and even that came in higher than our high strength nitrile. So our one step better, or multiple steps better, was this wear resistant nitrile, and that's really what we based much of the product line on, at least for these inner wear packers. So you can see that it only lost 8 milligrams of material versus 35 for our high strength nitrile and hundreds of milligrams for these other competitor products. So we're really happy with what we arrived at here, and that's just the beginning of it, right? So we start with the elastomer development, and from there it really expanded to an entire product line of packers. I'm going to show you some examples of those next.
And if I can add, Maggie, we have an OTC paper from 2018 that really goes into this elastomer development in a lot more detail, and the links will be provided to that at the end.
Yeah, good point. So one of the first styles we worked on is a telescopic joint or slip joint packer for a Cameron style riser. And this one's a little unique compared to some of the different riser styles, and I'm going to show them all to you. So in this case, we have a split packer that does kind of both jobs. It's sealing against the inner barrel and keeping the bore fluid, the bore pressure within, but it's also sealing against the actuating pressure. So your pneumatic or hydraulic supply that's actually pressurizing the packer and causing it to bow inwards and seal against the inner barrel. So this one does two jobs. And one thing that's unique about ours, I'd say, is that some of our competitors they'll mold like an entire full packer, and then they'll cut it in half, like with a bandsaw, and they'll glue in like a little tongue or here into a groove. And that's the way they get this seal, this tongue and groove seal. So that's how our competitors do it. We mold these in entire halves, and the tongue and groove is integral to the packer, right? So it's not something that's glued in, it's part of the mold, it's formed within the mold, and it's a highly engineered sealing surface here. And that's part of why we recommend to customers that they not put any additional sealant into that tongue and groove, because it can impact the sealing surface. So that is the Cameron style packer. Next, we went on to Vetco or Ocker style packers. It's really the same design for both of these in terms of the packer design. And this is a little different. You have two packers that are doing kind of two separate jobs. So you have an inner split packer, which is the wear packer that's running on the inner barrel. And again, it's got that integral tongue and groove feature. So that's something that's common amongst all our packers. They've got this, highly engineered tongue and groove seal between the halves, and the extreme duty nitrile, the very wear resistant material on the inner packer. And then this is a nested configuration. So there's an outer energizing packer that's sealing against the actuation fluid. So two different packers for the two different jobs. And again, this is a Vetco style. NOV style will look very similar. It's a nested configuration, slightly different dimensions on the two, but very similar to the Vetco style. Now, what's different here is our NOV style packers, we have both the inner and outer packer are made of nitrile, whereas our competitors run a urethane packer on the inside. And again, as I said before, urethane is a much stiffer material. So you'll see some data later on that shows exactly how different our packers are versus the competition on that actuation pressure that's required to get a seal. Those are the various configurations. One of the things we knew designing packers that we wanted to supply to the market, DJ packers, we knew that we would have to certify to API 16F. And not only that, but we knew that there was a change coming up. This was back in, say, 2016, 2017. We knew that there was a change coming up to 16F to bump it up to second edition, right? And so we knew we had to certify to 16F, and we might as well do it to second edition. I'm happy to say all our packers are certified to the latest edition, second edition of 16F. I'm going to tell you a little more about how we went through that process. And specifically, one of the challenges with 16F second edition is that it eliminated the ability to lubricate the inner barrel. The only lubrication you can use in second edition is water, and that makes for a much tougher test to pass. So in some ways, that's even more impressive that all our parts have passed this test, and honestly passed it with flying colors.
I'll kind of add there, Maggie, if you don't mind, that we did all of this of our own accord. We decided to do this and certify these parts to 16F second edition proactively before it was being required by the OEMs, before it was being required by the rig contractors, and then even the operators. And so that's just kind of the way we've worked. We got ahead of it, and then as the requirements were implemented and went into effect, then we went for a long time, and in many cases we're the only people with second edition certified packers. I know a lot of times people kind of wait, suppliers kind of wait around until they're made to make a change, but as we were introducing a new product, we just went ahead and jumped ahead of it. And that's kind of just the way we work. Do it right, do it the first time. And the test rig that Maggie's about to show you, we put a lot of money into developing this, and it's been just a great asset for us.
Yeah, that's good point. Okay, so on this slide, you see our API 16F test machine. This test fixture is in our Erie, Pennsylvania test lab. In this lab, we do elastomer and product level validation testing for multiple industries, not just oil and gas, but also aerospace, agricultural, industrial. Doing this type of testing is really part of our DNA. So we've established these core testing competencies, and given that, along with the cost of conducting this API 16F testing externally, which we would have had to do multiple times to qualify our entire TJ Packer product line, it made sense for us to establish our own internal 16F testing capability. Jonathan, anything else you wanted to add on that?
Another point to make along those lines, one possibility is kind of going back to that test machine overall. The inner barrel that we used, we went back to one of the co-chairs of the API 16F committee and sort of asked, what kind of surface finish, what would you do to that inner barrel? The response was, well, why don't you make it as rough and realistic as possible? Like, give me a worst case scenario, and that way when we do the API test, we have some feeling that's going to be okay when it gets to the field. And so not having grease was one of those factors that Maggie mentioned. And so the way we addressed the inner barrel was, that is a rough piece of line pipe. All we did for surface prep was we ground the line weld flush with a hand grinder, didn't do any sort of surface treatment, didn't do any sort of polishing. And there are, a lot of TJs out there in the world that have, very specific surface finishes. They certainly use grease while they're applying the TJ packer. And we have, that irregularity of the weld, and you can actually see that in some of the testing. You can kind of see a little bit of a line, a witness mark, where the packer rides on that weld. That kind of gives a little more background and flavor to the data you're seeing.
As I said, one of the benefits of having this equipment in-house is we could really show, like, I mean, we are intensely intellectually curious about our products, and we always want to go above and beyond and figure out how long they last and what are the weak points. And we've gone off and done that, right? It's been good to learn those results over the years and be able to share them with customers, because not only do you want a certified product, a product that's certified to 16F second edition, but you want something that performs better than what you're currently using. And now we have the data to show that. So that's been gratifying, and useful to have that test equipment in-house. Okay, so here you see some of the test data. This is hydrostatic test data for our packers versus the competitors. Now, we expected that our NOV-style packers would seal at a lower operating pressure since, as I mentioned earlier, our inner packer is nitrile, which is not as stiff as the competitor's urethane wear packer. So this upper chart you see here validates that, showing that for the various bore pressures, which you'll see along the horizontal axis there, our packers, which are the red bars, sealed at a 40 to 50% lower actuation pressure than the competitor's packer set, which are the blue bars you see there. We were somewhat surprised by the results in the lower chart here, which is our Vetco style packers versus the competitors. And our packers also showed a lower operating pressure than the competitors. The reason this was surprising is because both packer sets are nitrile, so we didn't expect to see this in this data. Some of it could be attributed to the sealing surface between the two halves of the inner split packer. So if you recall from a few slides before, ours are molded as two separate halves with an integral tongue and groove seal that's designed with an interference fit. The competitor, on the other hand, molds their packers as a full round version and then cuts them in half. This bandsaw approach doesn't lend itself to this highly engineered sealing surface between the two halves. So that could contribute to the higher pressure that you see in the competitor's packers, in particular the blue bars there, which is the split inner packer, the competitors. This also highlights another difference in our approach. So we recommend a split inner packer for both the upper and lower packers in Vetco systems. We know we have a reliable seal with that integral tongue and groove approach. So that's part of why we recommend that. It also, there are some additional benefits. If you're using the same inner packer for both your upper and lower chambers, it reduces the number of spare parts you need to stock on the rig or at your shore base. Another potential contributor to why we're seeing higher sealing pressures for the competitors' packers is that there was a latent defect in the competitors' packers, which we learned later on as we got into the wear testing, and you'll see that on the subsequent slides. Jonathan, is there anything else you wanted to highlight here?
Yeah, Maggie. So along the lines of operating at lower pressure, one thing we've heard from the rig contractors where that's useful is being able to have a true pneumatic over hydraulic redundancy, so that they could operate, primarily on pneumatics and then have the hydraulic backup versus having the hydraulics on as their primary. Then if anything happened, they weren't able to do anything unless they had a secondary hydraulic system. And so it just kind of fits more with rig operations without having to modify the rig from what has traditionally been done.
Okay, so you just heard about our packers and that they operate at a lower operating pressure. So now we want to launch our second poll question, which is operating pressure a concern for you? And what is the maximum pressure you'd like to see in terms of your actuation pressure for your packers? We'll give everybody just a few seconds to respond to that, and then we'll move on. Great, thanks everybody for your feedback on that poll question. This chart here, you'll see the red line is our Vetco style split inner packer with a nitrile outer packer. The blue line is our competitor's split inner packer. And again, this is the one that we had a lot of challenges trying to get to seal in the hydrostatic test. We had to go up to say 280 psi just to get it to seal at 25 psi bore pressure. And I think we kind of shocked it into place, and then we had a little more luck when we were running the wear testing, but still a pretty substantial difference from our parts to the competitor's parts. And the other thing, so we tried to do the full 16F wear test here, and we were doing okay. You know, it had a higher pressure, but then we get to 22 and a half, about halfway through the test, 22.5K cycles, and we had to bump the pressure up to 250 because it started leaking the competitor's packer. So we're going along okay for a while, about another 20,000 cycles, and then we get to 45,000 cycles, and we had to jack the pressure up a lot, 300 psi, and we still couldn't get it to stop leaking. We actually aborted the test at that point. We couldn't go any further, and we analyzed the source of the leak, and it was actually the competitor's outer packer. It had a bond line failure, which was kind of surprising to us, but honestly, we saw it happen again, and you'll see that and on some of the future slides. This was actually the second time that we tried to test the competitor's packer. The first time was the year before, so this was in 2018. We tried to do the competitor's packer through a wear test, and we had the same issue occur, right? We had the outer packer fail at the bond line, and this time we only got through 6,300 cycles. So it's kind of luck of the draw, right? We happen to have a bad batch of competitor's packers on both of these tests, and this was just a much worse batch because it failed at 6,300 cycles versus the 45,000 cycles that we saw on the test that we saw in the previous slide. And I'll say the other thing you'll note here is the level of elastomer wear you see in the test fixture coming off the competitor's packer. So just literally crumbs here, elastomer crumbs building up in the test fixture. And just you can see the pattern of wear on the competitor's inner packer here versus this is a Parker Lord packer, and you can see evidence of where it was contacting the inner barrel, but really no wear and honestly nothing measurable during that very short period of testing, which was just 6,300 cycles. And this, you can find more information about this in that OTC paper that Jonathan referenced earlier, and we'll have the link to that later on in the presentation. So this is a summary of those two tests. So the first one we did in 2018, where we only got 6,300 cycles completed and had a failure of the competitor's outer packer. The second one was in 2019. We got farther along, but again, the competitor's outer packer failed. It was just surprising to us. And part of that comes from the manufacturer where, we make Chemlock, which is the adhesive that makes rubber stick to metal. So we're very vertically integrated in that way. We make the adhesive, so we know the exact conditions that you need to get a good bond. We know how you need to process the metals. We tell, all our customers how to do that, but having that knowledge internally and having it just be kind of part of our DNA means that we don't get those bond line failures, right, that we saw in our competitors' part. So it was surprising to us that this was a differentiating factor. And also with the Vetco packers, we were surprised that the actuation pressure for ours was lower just because it's like nitrile versus nitrile. With the NOV-Style packers, we were not surprised that our actuation pressure was lower because you would expect that with a nitrile packer versus a urethane wear packer. All right, so at this time, we're going to launch our third poll question, and that is, how often do you experience a leak due to a bond failure with your TJ packers? So we'll give you a few seconds to answer that question, and then we'll move on. Great, thank you for your responses on that. Okay, so that was the testing that we did on the Vetco style packers. We also did testing on Cameron style packers, right? So, and we found really similar results, at least in terms of the wear performance. So this here you see is the competitor's packer before wear testing. And there's two of the competitor's packers in the chamber. They look pretty shiny and new, right? This is the competitor's packer after only 400 wear test cycles. So the entire API 16F wear test is 50,000 cycles. So we only got like a few hours into the testing, and we had pretty severe elastomer debris with these two competitor packers in here. It was so bad that we had to stop testing, clear out all the debris from the system, clean the filters and everything, and we started again. And we got about another 400 cycles in, and we had the same problem. So we stopped. We're like, all right, what can we do? We really would like to finish the 50,000 cycles on this. What we did was we had to change our test fixture to accommodate these kind of non-wear resistant packers, and switched out the filters, switched out the hoses and the fittings, everything. And we also said, you know what, we can't run two of the competitors' packers in here at the same time. So we pulled out one of these and put our packer in, this packer here, which I think at this point has been through the API 16F test 4 times. So put that packer in one of the chambers and kept going. With that reduced amount of elastomer debris, we were able to get through the test with fewer stoppages to clean out the debris. And you can see over here the post-test image of our competitor's part. And you can see that the elastomer is just, it's worn away from one section of the packer and kind of adhered itself to another section. So very uneven surface, looks kind of gummy. And you can see the wear marks from the inner barrel. And this is our packer. It almost looks new. I mean, you can see slight wear marks, but almost like it came out of the package. And in the end, we had 17 times as much elastomer lost from the competitor's part than we did. And that's just a pre-post test weighing that we do for one versus the other.
And I'm really glad we did this testing too, because it helped us sort of validate that the test wasn't a cakewalk, because the way our parts walked away from it, it looked like the test was a cakewalk, but this without the grease specifically, I think it makes it a more aggressive test. And this kind of helps validate that, in my opinion.
Yeah, that's a good point. So that's the lab testing that we've done. Not only the elastomer level lab testing, but the product level lab validation testing that we've done for our parts versus the competitors. And you can see the superior wear performance showing through on both packer styles that we showed there, and the lower operating pressure as well, and the nested ones. Plus no bond line failures or anything for the Parker Lord packers during the test. So now I'm going to hand it off to Jonathan, and he's going to tell you a little more about the field testing that we've done on our packers and some of those results.
So I like to say you can do anything you want to in a lab, but until you take it to a drilling rig, you really don't know what you have. And so continuing along our journey, we have done extensive field testing with several partners on the rig contractor side. And the first one shown here is the NOV-Style. And to give you some indication, again, ours is using the abrasion resistant elastomer, and the typical NOV one is a urethane. And so this is a test in South America. This particular packer went 10 months in service. It didn't fail. We had agreed to actually pull it after 6 months in service to evaluate it, and they did. And they looked at it, and it was in really good shape. And so they said, well, can we run it even longer in the well operation that they were in? And we said, yeah, that as long as you're at a consistent operating pressure, then that shouldn't be a problem at all. And they were actuating this at about 90 psi the whole time. And so this is what it looked like after 10 months. And you do see wear, but it operated fine and had a fair amount of life on it when we got it back in. Is there anything else you'd say about that test, Maggie?
I guess the one thing that was interesting on this one is that the wear's rather uneven. Like you expect with the packer, just the design of the system where it's got to withstand bore pressure on the bottom. You expect more wear on the top, like the top, say, third of the packer, just because it's kind of being forced apart by the bore pressure at the bottom. But you'd also expect it to be more even across that entire circumference, the ID of the part. And in this case, we saw some more uneven wear, maybe due to misalignment of the equipment or the condition of the inner barrel. We don't really know, but it's just something we observed that was different on this particular test.
Thanks for that. And you'll notice to the image on the right is a 3D scan of the part once it comes in. and versus nominal what the part was when it got shipped out. And so you can see the gray area indicates the biggest area of wear. And one of the honestly kind of goofy things we've done over and over again is our when we put it on the table to do the 3D scan, we often put the parts upside down. And so you'll see in a lot of these images that the 3D scans are upside down from the actual way the parts used in the field. But I think it's easy to see where we scan that. That's part of just the level of detail we go to as we work through these parts. The next example, this was actually our very, very first field test, and it's on the Cameron style packer. The story here is that this was our very first TJ packer using the new elastomer several years ago. And, you know, we had no name in this space really because we were a new entrant applying new technology. And of course, everyone was very nervous about trying this because it's kind of better the devil you know versus the devil you don't know. But what happened in this case was this was on a rig in Brazil, and they had a situation. Not sure if it's a combination of the mud system and the sea states that they have in Brazil, but they had a very aggressive wear on their TJ packers, and they had a situation where our competitor's part was literally only lasting like 3 days, and then they would put another one on. It would only last 2 or 3 days, and you can see how much wear happened in just a few days on that one. And they had our part sitting there for a field trial for a long time until they ran into this challenge of multiple packers being worn out. And I think they finally decided, well, this new packer that we've never heard of can't be any worse than what we're using. And so they finally took the leap of faith and installed our packer. And so the pictures in the upper right hand corner are what our parts look like after 3 weeks on the same well, and it looked basically brand new, and they were just flabbergasted. Meantime, they'd gone back to work with that rig and had another packer failure of the competitors, and they put this packer on a helicopter and rushed it back to the rig to install it because it had done so well. And so our first trial, kind of in a head-to-head application, we were very excited, but still, it was only 3 weeks worth of data, so it wasn't. It was good first indicator, but wasn't the whole story. And then that same packer went into service and did another 6 months, because that was our original intent, was put these packers for the first field trials in for 6 months and then evaluate them. And so you can see the amount of wear. And again, there's that 3D scan. This one's in the right orientation. And you can see how much wear we had on a rig that was having TJ Packer wear challenges after 6 months. And we felt really good about that.
And I guess,
Anything else you'd add about that story?
yeah, my favorite part about that, I think, is that it's just a great apples to apples comparison. You know, it's the same rig, same well, same crew. You know, because sometimes you'll have data like, you know, a part lasted 4 months and it was the same geographical region, but maybe different time of year or totally different rig. And in this case, you know, all variables were the same except they swapped out and put a Parker Lord packer in there, and it enabled them to finish the well and then do multiple more wells, you know, on that single packer.
So that was our first opportunity, and then we built on it from there. We had another opportunity to get a head-to-head comparison with about the same time period. So this is the same packer of ours on the right that you saw in the previous slides, and then the one on the left is our competitors' packers in about 5.5 months. And you can see the abrasion wore through the packer and actually created a hole. So just another good indicator of kind of what the longevity of the competitor's packer in a similar situation. It was on a different rig in a different time frame, but it gives us some indication of how we're doing. And that was a more recent head-to-head from the competitors that was reported back to us. So jumping around in time a little bit, this was actually our second field trial in the North Sea. And again, we were trying these for 6 months and then pulling them for inspection. So there were no issues with this trial. And you can see this one also had a fair amount of wear, that asymmetric wear like Maggie was describing, versus a new packer. You can see that on the picture in the right. And then you can see that 3D scan, which this one is in the proper orientation. You can see where the wear occurred. I think one thing to note on this, and we've seen this a couple of times in the North Sea, is you see that remnant of a white RTV or silicone sealant that was used in the tongue and groove, and we don't recommend that like Maggie said, because that tongue and groove is designed to have a specific interference fit, and RTV has the potential to create a leak path. I think that's just it's in our standard operating and installation procedures. Anything else you'd say about this field trial, Maggie?
Just we expected to see more wear, given the rougher levels of, rougher conditions in the North Sea on this one versus say like the Brazil field trial that we looked at before. And we didn't really see that in this case. They both kind of wore similarly. So that was a little surprising to us not to see more wear on this one.
And so here are some additional field trial results that we've gotten over the years. You can see the first one is 4 months from a rig in India. There was no failure mode. They were just used to running their packers for on the order of 2 months, and they pulled this at a convenient time, took some pictures of it, and they cleaned it up and kept it as a spare and put a new one on. Then the other examples from the Gulf of Mexico, again, just under 4 months, and you can see on there that it had minimal wear. We measured it and weighed it because we got to bring this one back into our facility to do some analysis on it. We only lost one pound of the elastomer, and again, you can see that the packer's upside down. But just some additional feedback from multiple rigs. We've had a fair amount of field history on these over the years now, and over the last 5 years, they've been on over 30 rigs, and we don't always get to know which rig and which region, and so we've depicted the ones that we are aware of, but they go to places we don't have full visibility to. But you can see multiple basins there around the world, many different rig contractors. A lot of people have converted completely over to our packers, and we have all riser styles available. And our typical in-service duration has been 4 to 12 months, and people are, as they get comfortable with the packers, they're pushing that further and further. And to our knowledge, we've had no abrasion or bond line failures. We've had some, I would say, some issues with just changing over to a new packer and using different gaskets and installation things. But we're always available to do follow-up and send those packers in, and we can evaluate them and give you feedback. We provide technical service support and installation instructions and everything like that. I think people have been really happy with our level of support, because at Lord, we use the phrase aircraft on ground for our aerospace business. And if there's an aircraft on ground, it's very expensive sort of proposition. And very much we view the rigs being down in the same way. We think of rig downtime the same way we think of aircraft on ground, and we treat it that way. And I'm very proud of the way the team has responded to any inquiries and technical support in the field that we've been asked for.
Yeah, we do have a very responsive and supportive tech support team.
As we've had more and more people use our packers and get comfortable with them, we've actually had service lives of over a year. We have one example where the outer packers were in service for 3 years, and they were still using those. And so as the reliability and longevity is just getting better, and people are getting used to that, it's really shifting the paradigm from a time-based to a condition-based maintenance. And so in an effort to assist the rigs as we've gotten feedback in figuring out, is it okay to put this packer back into service, our technical team developed a wear gauge so that you could, on the rig, put this gauge on and make that call in real time without having to call back to town or get in contact with us to see if we would support it. And those are just starting to ship out in with the packers. And so far, we've gotten good feedback on those, and it kind of puts the decision in the hands of the field whether they want to go to the next stage of putting the packer into service. At this time, we're going to post our final poll question: what criteria determines when you change your TJ packers? Thanks for your response. And one of the other things we're very proud of, and I think differentiates us in the industry is and Maggie touched on it earlier, the deep expertise in elastomer bonding. Like Maggie said, we're vertically integrated into the rubber to metal adhesive. We sell the adhesive to all the other major components and folks that make elastomeric parts in the oil industry. And we counsel them, and our tech service group supports those companies on how to do the rubber to metal bonding. And of course, we have that in spades internally. And we also have an aerospace mentality about process and consistency in our manufacturing processes. And so I always say that we want the thousandth part to be as good as the first part, so that the parts that you receive in the field are as good as the prototype and field trial parts that we put out and put a lot of labor and painstaking effort into. We want all the production parts to have that level of consistency. And one way we do that is on these parts in particular is the bond line integrity test. We talked about one of the failure modes is that debonding, which we were a little surprised by. That's what was happening in the field with some of our competitors' packers. And so if you do a pressure test initially on a TJ packer, and even if you have bond line issues, you can get a pressure test initially, but bond line issues and underbond corrosion in particular is a time dependent and an environmental factor. So if the packer sits in a warehouse or during shipping and it's not terribly protected, the rust or corrosion underneath the bond line between the rubber and the metal can grow over time. And so that's why you see packers that may have passed a factory acceptance test, but just a few months later you get them to the rig and they actually have a leak. And it's because that underbond corrosion will creep into your bond line over time and cause that weakness. And so what we do is we actually check that specifically as our end of line test, and we put it on this test machine where this wheel, as you see in the upper right hand corner, deflects the elastomer in, like your hydraulic pressure would be deflecting the elastomer in. And we have cameras that take a constant picture of that bond line, and then we keep a recording of that information per serialized packer. And so that way, if there are any issues in the field, we can go back and reference that to say if we saw any abnormalities in retrospect. But it also has an automated control system that it would detect those and flag those. And we've tested that control system to make sure we can flag any bond line issues. And that's your first indicator you're going to have bond line issues in the future, is by checking this before it leaves the factory. And so that's just one of many examples of the way we do things differently and the level of effort we go to make sure that the parts are good. Anything you'd add to that, Maggie?
This tester is looking at every single bond line. So there's actually like 4 cameras that are looking at the OD bond line, the ID bond line, looking for any of those imperfections. And it's magnified down to the level of that lower camera. And it has been valuable to have this information. Like Jonathan said, when somebody says, hey, we had a problem with this packer, and as soon as they tell us the serial number, we can go and pull this data and look at it and say, like, was there anything we saw unusual? And then we go through the whole troubleshooting support process that we talked about with that customer to try and help them figure out what the root cause is. And again, we haven't seen any bond line failures or abrasion failures for any of our packers yet, but we do help the customers figure out what could be causing the problem.
Absolutely.
We've shared with you some of the lab testing we've done, some of the experience we have with field trials of our parts. And so just some of the takeaways from what you heard today is our parts are certified to the 2nd edition of API 16F, which you also heard is a tougher test than it was, say, 10 years ago when some of the other packers out on the market might have gone through that. And increasingly, customers are requiring certification to 16F. Even if there's not a lot of new build rig activity going on, there's recertification of older TJs or T-joints that require so much work that you've got to kind of rebuild it or replace it to make it compliant. And then you do have to certify it to 16F 2nd edition. So the other thing, you saw the wear test data, you saw how our packers have performed in the field, and you can see that they're more reliable. And if you have a more reliable seal on your telescopic joint, you're going to be able to drill longer without non-productive time. And you won't need to stop in the middle of the well and change out a packer. You've even got, a wear gauge where you can kind of measure how much life might be left in that packer at the next point between a well when you want to check it, and you're able to do so. I guess, Jonathan, you want to share some of your takeaways from this?
Yeah, and one thing we haven't touched on in a lot of detail is that lower operating pressure. We've found an example where it allows true zero discharge, particularly on when we're replacing the urethane style, because the elastomer is softer. It has a better wiping action on the inner barrel to keep you from leaving any skin of drilling mud on there and having any level of discharge. And so we've had a really good experience. Wear hasn't been an issue on the urethane packers, but having that lower operating pressure and a softer, more compliant material allowed a wiping cleaner of the inner barrel to affect true zero discharge. And then the other thing I'm super proud of, again, as coming from a drilling background, is our field support and troubleshooting effort that we go to support the field. Because I mean, just speaking from experience, sometimes when things go wrong, especially when you're talking about a part supplier like us, folks will kind of stick their head in the sand or not answer emails, or sometimes they just don't have time to get back to you, really. But we really take this seriously. When questions come in from the rig, we try to move quickly to respond, and we don't hide. And I'm really proud of that approach we've taken. Thanks everyone for the time you've spent with us today. We appreciate it. And now I'll open it up to questions.